Okay, here we go, question 4. The cylinder water drains at the bottom. They give us the rate of change of the height of the water in the barrel is dH dt. Now let's remember that's dH dt. And they give us the formula for the volume of a cylinder. So part A, find the rate of change of the volume of the water in the barrel when the height of the water is 4 feet and indicate units of measure. Okay, so here's our volume formula, right? Pi r squared h. They gave us the diameter of the barrel is 2, so the radius is 1. So our volume really is just pi h. The radius is not changing because it's a cylinder. So dV dt is just going to be pi times dH dt. So dV dt is just going to be pi times negative 1/10 of the square root of h. Just subbing in, we get negative 1/10 pi times square root of 4, which is really negative 2/10 pi, or negative 1 pi over 5 cubic feet per second. It did say indicate units of measure, so you have to include those units. Part B, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time, increasing or decreasing. Explain your reasoning. Rate of change of the height of water with respect to time. They're asking, is dH dt increasing or decreasing? How do we know if dH dt is increasing or decreasing? We have to take the derivative of dH dt. So we have to find d2h dt squared. Okay, so derivative of negative 1/10 of the square root of h. Remember, square root of h is h to the 1/2. So that becomes negative 1/10 times 1/2 h to the negative 1/2 times dH dt. It's an implicit differentiation, so we have to include that. Simplifying that gives us negative 1/20 rad h, and then subbing in for dH dt times negative 1/10 rad h. Well, the rad h's cancel out, and negative 1/20 times negative 1/10 is positive 1/200. And since 1/200 is positive, the rate of change of the height is increasing at h equals 3 because d2h dt squared is a positive value. That was kind of a neat little question. Okay. Part C, time equals 0. The height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Separation of variables means we're going to solve this differential equation. Separate, put your h's with your h's and your t's with your t's. So we start with dH dt is negative 1/10 rad h. Put the rad h, basically cross multiply, okay? Or put the dt over on the other side, bring the rad h over, so we get dH over rad h equals negative 1/10 dt. Now, dH over rad h can be written as h to the negative 1/2. Oops, that should be a dH. Let me fix that. Okay, h to the negative 1/2 dH equals negative 1/10 dt. When we integrate that, we get, add 1 on, so you get h to the positive 1/2 times the reciprocal of 1/2, so times 2, equals negative t over 10 plus c. So now the question is, what are we subbing in for what value? We have to solve for c. We know at time t equals 0, the height of the water is 5, okay? So we fill in 5 and 0, and we get c is 2 rad 5. So now we have 2h to the 1/2 equals negative t over 10 plus 2 rad 5. And let's see, from that, divide both sides by 2, so we get h to the 1/2 equals negative t over 20 plus rad 5. And we get rid of the 1/2 power by squaring both sides. So h of t is equal to negative t over 20 plus rad 5, that whole expression squared. Okay, this is a good question because it's combining basically reading comprehension for part A, part B, little implicit differentiation, and part C, solving a differential equation. A little bit different than the slope field type differential equation. This is more like the ones we had on our test where it was like the weight of the bird or I think the other one was like the amount of trash being brought somewhere or something like that. Okay, so again, another good example of what they could do on the AP exam to combine a whole bunch of different topics into one question.